which is taking what we learned about vectors and applying it to the real world. So you did this first one and the last one you did back in physical science class. You might not remember it because that was a couple of years ago for some of you. But working with forces, we have a box and two forces act on the box. There's a force of 12 pounds going this way. And at a 90-degree angle from that, so 90 degrees is straight up, there's a 19-pound force. Okay? What is the magnitude of the resultant force and the angle of the resultant force? Okay? This, we could do our head to tail. So if that's 19, we transfer the tail of the 19 and go up to here. So it's 19 pounds. And then, from where we started, make a triangle. Okay? So, to find the magnitude, it's simply the magnitude equals the square root of 12 squared plus 19 squared, which is 144 plus 300 and something 361, which equals the square root of 505, which is 14 point something, Reese. What's the square root of 505? Yeah, why don't you pay attention up here, not back there. Okay, so it's 22 point what? 0.5. Okay, now we got to figure out our angle. How do we figure out our angle from the first lesson today? Inverse tangent of y, which is 19, over x, which is 12. What's the inverse tangent of 19 over 12? Are we in the first quadrant? Yeah, if the origin is here and we're going off this way, we'd be in the first quadrant, 57.7 degrees. Okay? Little physics for you. What? Round to the nearest degree. Hey, how about it's 58 degrees? How about I follow directions because they're right there in front of my face? All right. Now, my most favoritist trig problem of all time. Two prospectors are pulling on ropes attached around the neck of a donkey who's being an angle side right now because he doesn't want to move. At least some of you got that joke in more than one way. All right. One prospector pulls with a force of 60 pounds. The other one pulls with a force of 70 pounds. If the angle between the two ropes is 25 degrees, as shown in the figure, then how much force must the donkey use in order to stay put? Remember, for every force, there's an equal and opposite force. So if these two forces are pulling this direction at some magnitude, then the donkey must be pulling back at the same magnitude to not move. Okay? So we have to figure out the magnitude of these forces. Now, if these two prospectors who aren't not using their force to the greatest ability, because if they were pulling on the same rope, they'd be having more force than if they're pulling on two separate ropes. Okay, if they're pulling on the same one in a straight line, what would their force be? How many pounds of force? 130. It'd be exactly 130. But since there's an angle in between them, they're losing some of their pull. Not a lot, but a little bit. So how do we figure out how much pull they have? Well, we draw a picture. Because their force is going this direction. How far is it going in that direction? Well, if we make a parallelogram, that's not a very good parallelogram, Mr. Bierschbach. How about you fix that a little bit? That's a little better. If we make a parallelogram, and it's still not perfect, what do we know about opposite sides of a parallelogram? They're congruent. So this force is 70 degrees, 70 pounds here. And this force is 60 pounds right here. Okay? So I've all of a sudden made a triangle here. I have 25 degrees in between these two ropes. I can't use that 25-degree angle, but I can use that to figure out this angle right here. How big would that angle of the triangle be? What do you know about opposite angles of a parallelogram? They're congruent. So if I have a parallelogram, and this angle is 25, this angle here is 25, right? So that does add up to 50, right? How many degrees are in a quadrilateral? 360. If you take 360 minus 50, what's left to be shared by the other two? 310 is to be shared by the other two. So each of them is 155. What do we know about 25 and 155? They add up to 180. They are supplementary. Consecutive angles of parallelogram are supplementary. So once we know this is 25, we instantly know this is 155. Their force goes from here to here. There are two forces. Because if we use head to tail vectors, this vector here, and then we move this one over here, it goes like that. So this vector right here, there is a resultant vector. Okay? So if we have this, if this is 60, this is 70, and this is 155, I all of a sudden have what? A side angle side. And if I want to find the resultant vector right here, side angle side, what law do I use to figure out the resultant? Law of cosines. So the resultant squared equals 60 squared plus 70 squared minus 2 times 60 times 70 cosine of the angle in between, which is 155. You type that straight into your calculator and take the square root of that, and you figure out what the resultant vector is. How much force the two prospectors are pulling that mule with. So 3600 plus 4900 minus 2 times 4200 times the cosine of 155. Must be about 126, 125, somewhere in there, 124. 126.9 pounds of force is how much that donkey is pulling back so it doesn't move. Okay? Good problem. Last problem. Great physics problem. Here's an inclined plane. You saw those as freshman high school physical science students. There's a block of ice on it. But the block of ice isn't moving. So that means there must be a lot of friction on our inclined plane. Okay? Because it wants to move this way, but the force of friction is keeping it up on the plane. Okay? Now, the plane is 40 degrees. What other force is acting upon that ice block? Gravity. The block of ice weighs 70 pounds, so the force downward due to gravity is 70 pounds. Its force of friction goes this way to make a right triangle. Okay? So, since this line is perpendicular to our incline, which angles are 40-degree angle? This little one here or this big one down here? The little one is our 40-degree angle. Now our force of friction is right here, which is the same as this force. They're parallel forces. That was keeping it up. Okay? So if this is here and we have a right triangle, I have my angle. I have my what side? Opposite, adjacent, or hypotenuse? Opposite. And then this side I have my hypotenuse. So the sine of my angle, 40 degrees, equals my opposite side, the force of friction, over the hypotenuse, 70 pounds. How do I solve that? Multiply each side by 70. So 70 times the sine of 40 gives me my force of friction. Okay? So that's a little physics. Okay? Mr. Minert knows all about all this stuff because he's already in physics class. Those of you